what is the prime number and the composite number? So as we know that, okay, prime number is 2, right? Okay, the first thing is, okay, is a whole number. Is a whole number greater than 1? Whole number greater than 1. Okay, and then the second thing is that, okay, only has 2 factors. Okay, 1 and itself. Okay, so let's give some examples. Okay, so what are those things that you have only 2 factors? Also, it's greater than 1. So for example, we have 2, 3, 5, 7, and this 11, and 13, and so on, right? So all those numbers, we call them the prime number. So is a prime number, they only have 2 factors, itself, 1 itself. For example, this one. So this one, the 2 equals to 1 times 2, right? So they only have 1 and 2, and 3 is only 1 times 3, 5 is the 1 times 5, 7, and so on. Okay, so of course, if let's say on the opposite side, if let's say we have a 6, we have 1 times 6, we also have 2 times 3, right? So okay, in this case, 6 is not a prime number. So 6 have a 1, have 2, have 3, and itself 6, right? So we have a total 4 factors. Have 4 factors. So 6 is not a prime number. So prime number is a whole number. Prime number is a whole number. It's greater than 1. Okay, whole number greater than 1 and only has 2 factors. 1 itself. Yes, this is correct. This is correct, and this is not a prime number. So okay, let's look at the opposite. Okay, if not a prime number, so what is the number? Because it has 4 factors, this is more than greater than 1 is a whole number. So we have bring another concept. Okay, that is called composite number. Okay, let's remove this. Let's remove this. Okay. This. So on opposite side, so we have another number. So we call that. They also have 2 functions. They also have a 2 opposite number also have a 2 definition. So first, the other one is the first one is the whole number. Of course, this must be the whole number greater than 1. Okay, and they also has more than 2 factors. Okay, just now we give the example, right? Like a 6 at 1 times 6, 2 times 3. So in this case, so 6, how many factors? 6 got? So it's have 1, 2, 3. So 6 to have 4 factors, right? And then importantly, so it's a whole number. So in this case, so basically we say 6. Number 6 is a whole number. Composite number is a whole number greater than 1, and so has more than 2 factors. Okay, so let's compare these two. Okay, so let's compare these two. So basically, prime number is a whole number greater than 1 and only has 2 factors, 1 and itself, right? Composite number is also a whole number greater than 1, but it has more than 2 factors. Okay, so that's the difference, right? Okay, also take note about the other one. Also take note one more. Okay, so 0, 0 and 1. Okay, let's remove this. 0 and 1 is neither a prime number nor a composite number. Okay, just remember this. So 0 and 1, we don't call it as a prime number, nor a composite number. So it's not fulfilled. 0 actually have 0, 1 also have 1, and then also it's different from these two definition. Okay, prime number and then composite number. Okay, so now let's give some examples. Okay, let's do some examples. Okay, let's do some examples. Okay. Okay, let's say example 1. Example 1. So what's the example? So show and explains whether the following are the prime or the composite number. So the first one is A is A51. So okay, so B is another one. B is the 113. Okay, so let's analyze. Okay, let's analyze. Okay, if a number, okay, if a number is the divisible by a composite number, for example, it's 18. Okay, in this case, it's 18. Then it is divisible by the prime numbers, which are the factors of the composite number. So, okay, let's do an example like the 18. 18, how many factors 18 has? So 2 times 9. So here we have a 3 times 6, right? So in this case, how many factors have? Factors 1, 2, 3, 6, 9, and 18. So they're all the factors of 18, right? So in this case, so if a number is divisible by a composite number, 18 is a composite number, right? So then it's divisible by the prime numbers, which is the factors of the composite number. So if this number is divisible by the 18, so for examples, we have this 36. Okay, 36 divided by 18, so is how much? Is 2, right? Okay, if this is the case, so then 36 was definitely able to divide by 2, right? So in this case, is how much? Is 1, is 18, right? Okay, so and then also able to this one, first one. But like look at 3. So it also can be divided by the 3. 3 is also one of the factors, right? So in this case, how much we get? We get 12, right? We get 12, right? Okay, so yeah. So we also get 12. So okay, so long this is in this case because 2 and 3 is the factor of 18, right? So in this case, if the composite number 18, it can be divisible for one of the whole numbers. Okay, so then the factor of this composite number also able to be divisible. Okay, so therefore to determine whether a number is a prime number, so then we can check this is divisible by the prime numbers smaller than the given number. Okay, so that is very clear, right? So we just determine this. Okay, we determine all those smaller. We can divide by 9 also as well if we want. So we can divide by 9. In this case, 36 divided by 9, how much we get? So we got 4, right? Okay, so it's always divisible right here. Okay, we get a whole number here. Okay, let's look at this example. Let's look at the example. Okay. So in this case, so let's start to divide it. Let's go through the divisions of the A51s, but the prime numbers 1, 2, 3, 4, 5, 6, 7. I mean all the prime numbers. Okay, so it's the smaller than this given number. Okay, so let's go to exercise. So in this case, let's try the first one. So A51 divided by 2. Okay, so how much we get? Okay, A51 divided by 2. So here is 4, right? Okay, so here we get 2, right? It's 4, 1. So we get how much? 11. So 5. So we get 1 left, right? So in this case, the first one we can't get. We can rule out the first one. First one can't. This one can't, right? Let's look at the second one. So we'll go through all the elements of this. Okay, all the elements. We go through all the elements. 3, 5, and then this 7. Okay. 11, 13. Okay, and so on. Okay, so we'll go through all the numbers. Okay, so let's try this one. Okay, let's try this one. So how about the second one? A51 times divided by 3. So it's how much? 2, right? We have how much? 25. Then here about A. So we have 11, 3, 9. Okay, we have 2, right? Left. Okay, second one also can't. This one also can't. We also can't get. Okay. The next one, A51 divided by 5. So how much we get? 1, 5, 3, 5, 7, right? 35. So we have that 1. Okay, so in this case, the thing also we can't do that, right? So let's try 7. So 1, 7, 15. Okay. 2, 14, 11, 1, 7. So how much we get? We got how much? So we got 4, right? So it's 4. State balance 4. So in this case, count. Okay, then we draw out this. Let's come to the 11. 11, how much we can get? Put in 77, right? 77. So 5 gives us 8. So it's 8, right? So in this case, it's 81. So 81, we're going to put a 7 again. 77. So how much we get? 1 is a 4, right? Okay, so we left 4. So also count. So in this case, 11 also counts. So we will go to all the items one by one. Okay, we'll go to them one by one. Okay. In the end, we will continue to try this. Okay, let's draw on this one. So the next one, okay, it's A51, 13. So next one is what? Next number. The next number is this 17, right? The next number is 17, right? So after this is 19, right? Okay, after this is what? 23, right? Okay, and follow and so on. Afterwards, this is the 73. After that, 77, 79. Okay, sorry, it's 79. Okay, they are all the prime numbers. Okay, let's try this one. Okay, so let's try this one. So we have this A51 divided by 13. So in this case, is how much? So how much we get here? So let's put 7. No, not for 7. We put 6, right? 6. So okay, then we put this. So how much we get? 77, right? So 721. So 6 will become no, we can multiply 5. 5. How much we get? 5 and 65. Okay, so what we get? We get this 6, right? So come. So in this case, this one also cannot. Okay, so let's try this one. 17. 851, 17. So how much we get? Okay, so in this case, this is this is 7. This is 6. Can we put a 6? We can put a 6. We can put a 5. Okay, let's try 5. 5. Oh yeah. Okay. Okay, 3. Yes. Okay, we got a value, but we still get balance 1, right? We still got 1 here. So in this case, 17 also cannot. Okay, let's try this one. 851, 19. Okay, 19. Let's look at 19. So that's 4 divided by times 4. 4. Okay, we get this right? So in this case, we balance 9. Okay, so how much we get to come here? Can we times 5? 5. 4, 9. Okay, no, we can't. We can use 4. 4. We come back the same number. 76, right? So 76 in this case is how much? 5. This is 5. This 1. Okay. Again, cannot. Okay, let's try this number. So 851, 23. So with what do we get? We got times 3. Can we times 3? It's 9, right? 9 here is a 9, and then this is 7, right? This is 6, right? 6 here, right? So how much we get from here? So we got 6, right? Then we have 7, 16, right? Now we have 1. So how about the next one? We can times 7 or 6. Let's have 7. Oh, 7. Okay, let's try 7. 7 we get 1, 21. This is 14 plus 2. How much we get? 16. Okay, good. Okay, finally, we got this number right. Okay, this is right. Okay, we don't need to try the rest. Okay, so probably this one is also cannot, right? 29. So we get 2. We get 2. No, 2 count. We get 3, right? 3. 2. 6. 2 count. Okay, must 2 be 2. 2 in this case 2, 1, and 5. So in this case 7, 2, 1. Okay, anyway, 7. Let's try this. Let's try this 7. We try 9. Okay, 2 8s, I think. So I'm gonna get 6 2. Okay, 6 2 1. Okay, anyway, we can't get the whole number. Okay, so in this case, we can determine that. Okay, after trying so much. Okay, after trying so much. Okay. Okay, after trying so much, eventually we get this number. This is the okay number. This is the okay number. So from here we can see that. Okay, how much we get? So 851 equals to how much? And 3 just now is how much we get? We get 37, right? Okay, so in this case, 851 is divisible by the 23, so we get a number, the whole number 37. Okay, so in this case, okay, so then we can see that. So 851 is a composite number. Okay, it's a composite number. Okay, it's not a prime number, it's a composite number. Okay, now, okay, so it's a composite number. Okay, this is clear, right? So let's look at 113. Let's look at 113. Okay, we apply the same concept. Okay, let's try all the prime number below smaller than 113 one by one. Okay, let's do the one by one. So, okay, 113. So 113 we have this. The first one is what? So 113 divided by 2, 113 divided by 3, and then 113 divided by 5, 7, and 11, right? 113, 113, 113. Okay, let's try that one. Okay. How about the first one? First one is 113 divided by 2 is 5, 10, 13. Okay. Here how much we get? We can put the 6, right? And we balance 1. So first one count. Okay, that's the second one. 113 divided by 3 is a 3, 9, 2. Okay, so how much we get? Can we get 7? Got 2, right? So count. Let's try 5. 113, so 2, 10, 13. Okay, so let's 2. 2, we still balance 3, right? So this one count. How about this one? 113 divided by 7. 1, 7. You got 4, right? 3, 6, right? We still balance 1, so it's count. How about 113, 11, 1, 10. We still balance 3, so count. Okay, we can continue to try. Maybe try one more until we try. Okay, so eventually we'll find out. No. Okay, so we can find out is that 113 is a prime number. Okay, because 113 is not divisible by any prime number. So which is less than 113, and this is only divisible. So 113 is only divisible by its one and itself. So therefore, we see 113 is a prime number. Okay, so that is the answer. Okay, so this is example 1.